बिस्मिल्लाहिर्रहमानिर्रहीम अस्सलाम वालेकुम स्टूडेंट्स। आज हम बोहर एटॉमिक मॉडल स्टार्ट करते हैं। सबसे पहले जो बात है कि बोहर एटॉमिक मॉडल इज़ यूज्ड ओनली फॉर हाइड्रोजन एटम और हाइड्रोजन लाइक एटम्स। फॉर एग्जांपल अगर हीलियम को हम कंसीडर कर ले या लिथियम को कंसीडर कर ले, सो व्हेन हीलियम एंड लिथियम बोथ लूजेस इलेक्ट्रॉन्स एंड दे हैव वन इलेक्ट्रॉन विद देम, so it will be considered as similar to hydrogen atom। उस केस में फिर हम उसको भी स्टडी कर सकते हैं। सो बोहर एटॉमिक मॉडल जो है सिंपलेस्ट एटम को एक्सप्लेन कर सकता है, लेकिन जिनमें इलेक्ट्रॉन ज़्यादा हो जाए उनको एक्सप्लेन नहीं कर सकता। सबसे पहले पोस्टुलेट्स पे आते हैं कि व्हाट आर द पोस्टुलेट्स ऑफ बोहर एटॉमिक मॉडल। अकॉर्डिंग टू बोहर एटॉमिक मॉडल, इलेक्ट्रॉन्स विल रिवॉल्व अराउंड द न्यूक्लियस in fixed circular path, which will be called as orbit, or it is also called as shell, or it may be called as energy level. Why these are called energy level? Because each orbit electron have definite energy, therefore these orbits are named as energy levels. Whenever electron revolve in the same orbit, its energy will remain same, its energy will remain constant till the time it jumps from one shell to another shell. So as long as an electron remains in the fixed orbit, it doesn't emit or absorb energy. This means that energy of electrons in any orbit remains constant. An electron can absorb or emit energy when it jumps from one shell to another shell. अब कैसे ये एनर्जी एब्जॉर्ब और एमिट करेगा? Whenever it jumps from lower shell to higher shell, so it will absorb energy, and when it jumps from higher to lower shell, it will emit energy. And remember, energy emitted and energy absorbed, they both will be same. जो एनर्जी ये लोअर शेल से हायर शेल में जंप करते वक्त एब्जॉर्ब करता है, सेम एनर्जी ये जब हायर से दोबारा उसी लोअर शेल में आएगा, सेम अमाउंट ऑफ एनर्जी ये रिलीज़ भी करेगा। सो एनर्जी बिफोर एक्साइटेशन एंड एनर्जी आफ्टर द एक्साइटेशन, दे बोथ विल बी सेम बट विद एन अपोजिट साइन। उसके साथ जब ये एब्जॉर्ब करेगा तो पॉजिटिव साइन के साथ होगा, और जब ये एमिट करेगा तो फिर नेगेटिव साइन के साथ होगा। अब what will be the difference in energy of these electrons when it jumps from one shell to another? That difference is denoted by delta E, and delta E हमारे पास बराबर है E2 minus E1 के, where E2 is equal to higher shell and E1 is equal to any lower shell. If we consider this delta E, so delta E is equal to h nu, and h nu में से जो हमारे पास h है, that is called as Planck's constant, and nu is frequency of radiation emitted or absorbed by the electrons. Whenever electrons are revolving around the nucleus, so they have certain angular momentum, and that angular momentum of an electron in any orbit is equal to h divided by 2 pi, or it will be somehow the whole number of multiple of this h divided by 2 pi. For example, अगर हम इसको whole number consider करते हैं, then MVR will be equal to n multiplied by h divided by 2 pi. जहाँ पे n हमारे पास क्या शो करता है? It is basically the number of shells. It is starting from 1, 2, 3, 4 and 5. It can never be 0 because 0 means there is no shell. So there must be a shell in the atom. MVR में हमारे पास जो m है, that is mass of electron, v is velocity of an electron, and r is the radius of the orbit. Next postulate of Bohr atomic model is each line in the line spectrum is obtained when an electron jumps from one of the higher shells E2 to one of the lower shells. Now it depends upon which shell is the higher shell. It may be shell number 5 and it jumps from shell number 5 to 4. Electron may jump from 5 to 3, electron may jump from 5 to 2, 5 to 1, and any shell will be there. Or it may be shell number 2 to shell number 1, shell number 3 to shell number 2, shell number 4 to shell number 3, and so on. Now again, this difference in energy of the electrons in different orbits, that will be calculated from the equation that delta E is equal to E2 minus E1. Now remember that these are the main postulates of Bohr atomic model. After this we will go for the applications of Bohr atomic model, that what are the importance of Bohr atomic model. So basically this Bohr atomic model is used to calculate the radius of electrons in an orbit, and secondly it is also used to find out the energy, wave number, and frequency. So after this lecture we will go for the radius of the hydrogen electron in hydrogen atom.